In this clip, you will learn to use pandas and NumPy to encode your categorical feature. Here we are in the Jupyter Notebook. First feature that we want to encode is the gender attribute. As this is a binary feature, so we can use the NumPy where function to easily encode this feature. We are creating a feature is male by comparing the gender with the string literal male, and if it is true, we are assigning it as a value of 1, otherwise 0. Let's execute the cell. Then in the next cell, we are performing several feature encoding in one go. And we are using the one-hot encoding technique. In pandas, you can use the very handy get_dummies function to encode your categorical features. In fact, you can pass all of the columns that you want to encode by passing the column names in the columns property of the getDummies function. The first parameter is the data frame itself. So we are encoding the deck, passenger class, title, fare bin, embarked, and age state features. Well, actually I'm doing some kind of cheating here. Age state is a binary feature because if you recall, it contains only two categories, adult and child. So you could have again used the NumPy where technique to encode it as a single feature such as is adult or is child. But that is the beauty of getDummies function. It won't mind if you pass a feature with only two categories. So you could have done the binary encoding as well for age state. And I encourage you to try the other parts as well. I have added the age state binary feature just to showcase the possibilities. Also, notice that we are assigning the output of the getDummies function to the data frame itself to override the contents. Let's execute this cell. So now we have encoded the bunch of features. Let's use the info command once again to see the state of our data frame. So now we have 39 columns with us. If you see, we still have few columns not numerically encoded. So we have the cabin feature here, but we have already used it to create the deck feature. So we can remove this feature from the data frame. Then we have the name column, which we use to extract the title. So we don't need this feature either. Then we have the ticket feature. Well, this is also an interesting feature. And I again encourage you to look into this feature and see if you can derive some useful features from the ticket information. But we will drop this feature as well for now. We have also used the PArch and SIB_SP column to create the family size feature. So we'll not use these two columns later. Also, we have created the feature of isMale using the sex attribute. So we can remove the sex column as well from the data frame. So let's remove all the extra features and let's also reorder the columns. I always prefer the column that you want to predict as the first or the last column in the data frame. So in the next clip, we will see how you can drop and reorder features from the pandas data frame. In this clip, you will learn to use pandas to drop and reorder columns. Here we are in the Jupyter Notebook. Well, in order to drop the columns, you can use the pandas drop function on the data frame. You can pass the column names that you want to remove from the data frame as a list. Here we are also specifying the axis property to 1 so that the drop function can work on the columns. Then we have set the in-place property to true as we want to change the data frame itself without creating a copy of it. So let's execute this cell. So now we have dropped our columns that we will not require in future. Let's reorder our columns as well. In the next cell, we are first creating a list of columns using a simple list comprehension and by iterating over all columns of the data frame that you can access using df.columns. We are also excluding the survived column from the list. Then on the next line, we are adding the survived column in front of the list. And once we have the order of columns, we are passing the column list in the square bracket. We are also assigning the data frame with reordered columns back to the original data frame. So let's execute this cell. Now let's use the info command once again to check the final status of the data frame. So we have our survived column on the top of the list. Then we have all other features which are either integer or float. So finally, we have done all the hard work to convert the raw data to the processed data. Let's save the processed data and write them to files in the next clip.